Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway system specialist. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. On the Railway Transportation Systems podcast, we are joined by one of the most respected signaling and rail systems leaders in Australia and abroad, Akshaya Malaviya, a fellow of both Engineers Australia and Institution of Railway Signal Engineers. Akshay brings more than 30 years of hands-on experience across Indian Railways, ARTC, Queensland Rail, Metro Trains Melbourne, UGL and Interface Rail Engineering. His career spans major brownfield and greenfield programs including the Melbourne Metro Tunnel, Hunter Valley capacity upgrades, Queensland Rail network reforms and New West Alliance signaling program in Perth. Akshay specializes in high-capacity digital signaling, systems integration, safety assurance and engineering management across multidisciplinary teams from CBTC and ETCS to stakeholder governance, risk management and technology transition. He has shaped the systems that keep our railways moving safely and reliably. We are excited to dive into the technical, managerial and strategic aspects of modern rail systems with someone who has led signaling and train control transformations at scale. Hi Akshay, welcome to the pod.
Thank you, Rahman. Yeah, so nice of you to have me here. Thank you so much.
Let's start with more rail-specific questions, which are specially designed to help for our professional and technical audience. So my first question to you is system focused. You have seen or you have overseen both CBTC and ETCS level 1 deliveries. What are the biggest integration challenges when transitioning from legacy signaling to modern high capacity digital systems?
See, Rahman, one of the biggest challenges is managing the interfaces with legacy interlockings and trackside equipment while introducing new digital systems. You're often dealing with a mix of old and new train-borne equipment. So compatibility becomes critical. On top of that, migration has to be staged very carefully so day-to-day operations can continue safely, often in mixed mode for long periods and with limited access to the railway. There is also a strong people and performance aspect. Training operations and maintenance staff to work confidently with new technology, achieving consistent train stopping accuracy, enforcing speed regulation under digital supervision, and managing EMC issues between new and existing equipment, both internal and external. All of these need to come together to deliver a safe, reliable, high-capacity system.
Great. Then for mixed mode operations like those on the Melbourne Metro Tunnel, what are the top system assurance risks that must be managed, Safar?
See, the highest risks typically arise from mode transitions between CBTC and conventional signaling. Also, degraded mode behavior and human factors at system boundaries. Ensuring data consistency between systems, clear allocation of authority and operational rule simplicity is also critical to demonstrating risks are reduced so far, which is so far as is reasonably practicable.
Is there any difference between SAFARP and ALAP?
Yes. So in Australia, we have adopted the SAFARP kind of risk management criteria. In the UK and in some other places, they go for ALAP. So that the difference is so far as is reasonably practicable, and ALAP is as low as is reasonably practical. So there is a subtle difference between the two, and it does make a difference when you design your signaling system.
Great. Akshay, from your experience in designing and reviewing safety cases, what are the most common pitfalls projects encounter in demonstrating functional safety compliance with EN 50126, 28 and 29?
Rahman, projects often start safety activities way too late. And this results in weak traceability between hazards, requirements, and evidence. Independence is sometimes poorly managed, and safety cases are treated more as a documentation exercise rather than as structured demonstration of how safety has been engineered into the system. So that makes a huge difference.
Akshay, can you also explain how signaling principles need to evolve when incorporating CBTC into a brownfield corridor with existing interlockings and ATP systems?
See here, evolution is the key, Rahman. Signaling principles must evolve from fixed block dominance to continuous supervision and movement authority concepts, while clearly defining fallback states and interlocking limits of authority. Particular care is needed to manage coexistence with legacy ATP systems and to ensure predictable, conservative behavior in degraded and transition modes.
Well, Akshay, then what are the key considerations in planning and staging signaling cutovers on high density networks to minimize operational disruption?
Cutovers are really tricky. It requires a lot of planning. Successful cutovers rely on incremental staging. If you are doing your staging incrementally, then the probability of achieving success is higher. So, and you need to have proven fallback arrangements in place, and extensive operational rehearsal is also required. Engineering, operations, and rule changes must be tightly integrated with a clear go, no go criteria and contingency plans to protect network performance and safety.
Great insights, Akshay. Short and crisp. I know you have delivered major triplication and capacity enhancement works in the Hunter Valley. How do you balance signaling design optimization with operational flexibility for freight networks?
Yeah, as they say, we should not be going for the overkill or over design in those corridors, in those networks, because those are freight networks, but still you have to achieve safety. So every network, every railway network has to be 100% safe. So in freight networks like the Hunter Valley, the balance is achieved by designing for operational robustness rather than just peak theoretical capacity. Signaling has to accommodate long and irregular train consists, permissive and degraded modes, and frequent non-standard movements that are part of day-to-day freight operations. And at the same time, the design needs to allow for future growth without over constraining operators. So flexibility, recoverability, and ease of operations, these are the key factors, and these are just as important as headline capacity.
Great answer, Akshay. Thank you for sharing this on this platform. I'm pretty sure our audience would be enjoying this from you. Now I'll move from technical and system focused questions towards integration, assurance, and engineering management type of questions. What does effective systems integration governance look like on large multidisciplinary rail programs? And how do you ensure alignment between signaling, rolling stock, comms, PSTs, and control systems?
See, effective systems integration governance really starts with having clear technical authority and well-defined accountabilities across the program. What you need is a disciplined interface management. So responsibilities between different disciplines like signaling, rolling stock, communications, PSDs, and control systems. And then also track. That needs to be 100% unambiguous. Just as important is integrated verification and assurance planning. So each subsystem is not only correct in isolation, but proven to work together as a whole. Early alignment of assumptions and operating concepts across all disciplines is critical. That is what prevents late rework, integration surprises, and assurance gaps as the projects moves towards commissioning. This kind of whole of project application of these principles, we start with the concept and then through to commissioning, we keep applying these principles.
Well, how do you manage engineering configuration changes and type approvals across multiple suppliers while maintaining this network safety and consistency?
This is more about having systems, well designed systems and processes in place. So the whole thing is achieved through strong configuration control, formal impact assessments, and a centralized type approval strategy, which I'm sure most of the RTOs are already having a centralized type approval strategy. So decisions must be safety led with clear visibility of network wide impacts rather than subsystem specific optimization. So this is all about having good systems in place.
Great. So I'll go more into a question which is more specific to you. On the Metro Tunnel project, you have reviewed nearly 500 system artifacts. What frameworks or processes allowed you to maintain rigor at that scale?
So Metro Tunnel project was one of the projects that I have worked on. It was such a project where everything from a very small technicality to big technical issues, big technical problems, everything has been so well documented. So everything is documented, all the plans or the technical documents, everything was created by the delivery agency and it was reviewed by the RTOs and then delivery authority and state government representatives there associated with the project. So what we gathered from the whole system and process that was put in place, that a risk-based approach is essential when you review those documentation. The artifacts, like reviewing 500 artifacts is not easy.
Yeah.
But you need to have a risk-based approach. Once the approach is defined and well structured, then that will facilitate the review and then assurance activities. So risk-based approach, and this includes structured assurance frameworks, clear acceptance criteria, prioritization based on safety and operational impact, and consistent traceability is the key. Consistent traceability back to the system requirement and hazards. Once that is done, then you are sure that you are able to maintain rigor at that scale continuously.
Great answer, Akshay. I got one follow-up question. What's the difference between a risk-based approach and judgment of significance?
Risk-based approach is just like when you analyze anything or when you assess anything, the key driver is risk. You're analyzing or assessing a thing based on what risks are created by that thing and how those risks are mitigated by the system and things like that. And what is the other thing you asked?
Judgment of significance.
Judgment of significance. Judgment of significance is a concept that is used in systems engineering almost everywhere on every single project. Because the judgment of significance and the SAFAP principle, they go hand in hand. So judgment of significance determines what is a low risk and is acceptable. And we should not be going into a lot of detail in that particular thing. And then similarly, so the levels of risks and levels of impact on the systems of operations and everything. So that is where judgment of significance is very similar to SAFAP. So when you develop a SAFAP argument, it is basically to prove that if a risk is introduced on the system, how severe that risk is going to be, and then what is going to be its likelihood, what is going to be its impact, and whether that risk is acceptable or it needs to be mitigated prior. Before a system is put into use, if that risk needs to be mitigated, we'll have to manage that. So that's where judgment of significance comes into the equation. Like what kind of detail you will be going into. Like say, when you are reviewing a design or when you are reviewing a documentation or you are applying any principle anywhere, then judgment of significance plays a pivotal role. Like how much effort is required. And this is basically, I shouldn't be using the term cost benefit here, but it is kind of cost benefit. So how much effort you are putting in, and then whether the effort you are putting in is proportionate or is commensurate with the benefits you are achieving. So
Great.
that's where it balances. Yeah.
Great answer, Akshay. Thank you for bringing this because most people get confused between these two. And how do you approach defect management and workarounds during commissioning phases when deadlines are tight but safety cannot be compromised?
The first step is early classification of safety and operational impact. Temporary operating conditions are enforced where required, and all workarounds are formally assessed, documented, and time bound to ensure that they do not become de facto permanent solutions. So, that is very, very important to remember. Whenever a workaround arrangement is put in place, that must be a temporary arrangement. And everyone should know until when this temporary arrangement is going to be in place. And during that time, final solution or final arrangement has to be devised and then put in place.
Great insights. In your view, what capabilities are essential for an engineering team delivering major rail systems, and how do you build competency in emerging technologies like digital train control?
See, key capabilities include strong systems engineering discipline, safety assurance expertise, deep operational understanding, and ability to integrate new digital technologies into complex legacy environment. Building competency requires mentoring, exposure to live projects, and structured knowledge transfer.
Yeah, that's a very crisp answer. I will deep dive a bit more specific to you. So, I know you have worked in almost every state in Australia. What challenges, particularly, you faced in achieving signaling competencies in each state? What are they, and can you list them out? How to achieve them, please?
Yes, I can do that because except for South Australia, I have worked everywhere. I've worked in Queensland, New South Wales, Victoria, and Western Australia. The signaling competency management frameworks across Australian states are all underpinned by the common objective of ensuring that designers and checkers signing off signaling designs possess adequate design experience and the required domain knowledge. The accreditation process is relatively simpler in Western Australia and South Australia, where project based accreditation is offered by the RTOs based largely on designer CVs. Queensland also follows a similar approach, but with a more structured process. There, the RTO accredits designers through formal assessment and does not restrict accreditation to individual projects. On the other hand, New South Wales adopts a markedly different model under which designers are not assessed directly by the authority or RTO. Instead, design houses conduct their own competency assessments and accreditations, which may be subject to scrutiny by TFNSW or the RTO. Victoria and ARTC apply the most stringent frameworks, with assessments typically conducted by accredited assessors. All these assessors are generally external. So these are conducted by accredited assessors through a structured process. Following recommendations from the Signaling Strategy Task Force in Victoria, this state has introduced a two-tier assessment model. Candidates are first assessed against national competencies or roles, then required to complete a domain-specific course which covers Victorian speed signaling, and this is used to achieve Victorian competency. So two-stage process. A significant change in Victoria is recognition of IRSC licenses, which wasn't being done before, but it has now been allowed, which is really good. However, the new framework has increased the cost burden for candidates and also the employers. But it is what it is. We have to achieve competencies through the given process only. And I'm told ARTC is also expected to adopt a similar approach going forward.
Great insights. Thank you for sharing this, Akshay. And I will now move from engineering management type of questions into more strategic business cases and industry trends. So with that, can you, Akshay, you have contributed to several business cases. What signaling related assumptions or cost drivers are most often misunderstood by stakeholders?
Yeah, see, this is a very good question, Rahman. So I've been associated with several business cases, and I can say with conviction that stakeholders often underestimate migration complexity, brownfield integration effort, long-term support, and obsolescence costs. And they also sometimes underestimate the ongoing cost of maintaining legacy systems alongside new digital systems. So this definitely creates a complex environment, and sometimes it is, or many a time, this is underestimated, or the complexities are ignored.
Great answer, Akshay. So, with growing interest in automation and single driver operations, what technical and safety preconditions must be achieved for a railway to consider such transitions?
In my opinion, Rahman, railways must demonstrate highly reliable train protection, well defined and tested degraded modes, mature operational rules, strong cyber security, and consistent system integrity supported by robust assurance evidence. So, in my opinion, assurance evidence is the key actually. So if we are able to get that on every project, then yeah, we can achieve what we want to.
Akshay, looking at your experience since you worked in abroad, especially in India and Australia, and if we look into the projects going around, deployed around the world, how do you think the competencies must be developed? So, if a person from India or anywhere around the world, like Turkey or Egypt, if they want to migrate to Australia or Europe, how do you think we can make this ease?
See, Rahman, if you talk about competencies, particularly in the signaling discipline, different countries have got their own frameworks. And Australia has got so many states, and every state has got a different competency management framework. So it varies from state to state, and it varies from country to country. But the most acceptable or most widely accepted competency management framework across the world in signaling discipline is the IRSC framework. So anyone who has achieved an IRSC license in a particular competency element, that is generally accepted as a given, like that person is competent in that particular element. And Australia wasn't accepting that before, but I think Victoria is leading the country in that regard, and IRSC license are now being accepted. So from my perspective, if we want to develop competencies in signaling, the first step for anyone is to achieve an IRSC license. A person can really make a set of objectives, which competency elements that person wants to work in, and then that person should try to achieve IRSC competencies or IRSC licenses in those areas. And then once a person goes to a different country where IRSC license may not be enough, they may have to go for the local domain knowledge as well. But once the IRSC license is obtained, I think 60% to 60 to 70% competency is achieved already. So what you need to achieve later is only the domain competency. That's all.
Great
So
answer.
So from my perspective, IRSC license is the key.
I see you're a great supporter of IRSC. So, in your terms, anyone who wants to have a global competency for signaling, so IRSC is the base.
It's the first step.
Yeah, first
Yes,
step.
IRSC is the first step, or it's a stepping stone. Once you have got that, yeah, the job is half done already.
Great answer, Akshay. Now, looking ahead, what do you see as the most impactful signaling or rail systems innovations that will shape the next decade of rail transport?
See, Rahman, the digital signaling is very new, and the CTCS level 2 and CBTC systems are being rolled out everywhere across the world. The next step in digital signaling will be two things. One is ETCS level 3 might come someday in a big way, and also the communication protocol used by CBTC and the ETCS system. Currently, ETCS works through GSMR, and then CBTC works through Wi-Fi. So once GSMR, as we know, is going to be obsolete anyway. So there will be some, I think, in next 5 to 10 years, the new system will be, the new communication protocol will be in place, and that might impact CBTC as well. But the most impactful change over the next decade in signaling will be the shift from standalone signaling systems to integrated data driven train control and operational platforms. We'll see tighter integration between signaling, traffic, and operations management and rolling stock. And this will allow networks to use real time data to manage capacity, recover from disruption, and optimize performance at a whole of system level. Alongside this, greater system standardization, advanced traffic management, and data driven maintenance will help railways get more out of existing infrastructure before needing a major capital expansion. So all this, if you summarize, it's not actually artificial intelligence, but the whole world is drifting towards AI and ML, and that is going to impact on some maintenance processes that the RTOs have got now. There will be more emphasis on comparing the actual situation now on a real time basis with the historical situation, and coming out with the answers to the problems. So this is going to happen. And if you talk about signaling specifically, then I think next step will be, in my opinion, is going to be ETCS level 3, and then some changes in the way the digital signaling uses communication.
Wow, great insights, Akshay. Thank you very much from the bottom of my heart to come onto this platform and sharing your insights with us.
Oh, thank you so much, Rahman, for giving me this opportunity. It was so great, actually, and your questions were thought-provoking questions, and I really I'm impressed with the way you have developed a questionnaire. I tried my best to answer based on my own experience from here and also from India, actually. So whatever I have delivered or whatever I have done in the rail sector, so tried to take a lot of cue from those things, and present answers to you in such a way that it's well understood by everyone.
I think you did pretty well, Akshay, and I'm sure our audience would enjoy your pod.
Thank you so much.
I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story, or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry, contact me on railwaytransportationsystems@gmail.com. Thank you for your time today. Stay safe and take care of yourself.